So on our home stretch then, the resultant for that particular example is 674 newtons, and the direction would be east, 5 degrees north. Now they wanted the acceleration, so just to finish that off, with our unbalanced force, mass times acceleration. So we know it's 674 is the unbalanced force. Mass is 10 times 10 to the 6 multiplied by our acceleration. So when you do the division there, your acceleration is 6.74 times 10 to the negative 5 meters per second squared. And that is in the direction of the unbalanced force. So there we go. So there's the final answer. So therefore, acceleration is. All right, so acceleration can be calculated from the vectors, similar to velocity and displacement last year in the grade 11 course. All right. So let's talk about the inclined plane again for a second. This was, I like to teach it in the grade 11 course just on how to calculate your forces. So the theta, and we'll do this from a free body diagram just to refresh everyone's memory. So your force due to gravity is a vector that looks like that. So there's your force due to gravity. Your normal force is always perpendicular to the incline. Your force of gravity pulling it down the x-axis, we'll call it. The x-axis has been shifted here. There's your FAX. All right. And then your force due to friction is in the opposite direction. So there are your four major vectors. Now, the geometry here. If I extend that normal line as such, what we can do is I can move theta to the location I want it. So force due to gravity here, that would mean that that triangle, I'll do it in a nice yellow. So I'm looking at this triangle. I know that the angle in the top corner here would be 90 minus theta, and that's from 180 take away 90 take away theta. Now, I also know that that dotted line that I just put in right here, this creates a 90 degree. So if that's the case, this angle right here would be 90 take away 90 minus theta, which turns out to be theta. So that's really the formulas I'm going to generate, and the ones I generated in the grade 11 course come from the fact from geometry that theta is actually located right there. So that being said, your formulas here, force due to gravity again, is mass times g. If you want to calculate the normal force, Fn, it will equal, for us in this case, the magnitude of the force due to gravity. And we are looking for the component, get the magic pen, here we go. We're looking for this component right here. So we're going to take that vector and find the component. So that would be cos theta. It's because it is the value that is connected kind of to your x-axis when you did your vector notation. So normal force is calculated with that. And our FAX, force down the incline, force due to gravity, sine theta. For people that aren't in the course, I'm not going through the geometry in much more detail than I am already because I did do it in more detail in the grade 11 course. So this is straight review for people or students that are taking the grade 12 course right now. So if you want, you can go back and look at the grade 11 course in the end of the second unit, and you can see the more detailed explanation. So how does this work? Here's an example. Kayla is driving her Kawasaki street bike up a ramp that's inclined at 35 degrees. So here is my ramp. Here's my 35 degrees. Here is my Kayla on a bike. She knows that she will experience a frictional force of 1,000 newtons on the ramp. So it tells us the value. And because she's going up the ramp, force due to friction is going to be opposing motion. So it's actually heading down the ramp. So that's 1,000 newtons. Her bike will accelerate at 3.5 meters per second squared. And that would be up the ramp. So I'll just put up. If the mass of rider and bike is 175 kilograms, mass equals 175 kg. What force must the engine generate? So we are looking for F applied or F motor. So let's go FM just to be cool here. All right, so we're looking for the force that the motor will apply. So let's finish off my free body diagram here. So Kayla's bike, we have a force due to gravity. We have an FAX in the same direction. The motor force is going to be pushing up the slope. And there's my normal force. So we're going back to our FU ma. All right, so FU ma, we want to know the unbalanced force. So the unbalanced force, because we want acceleration, is that I'm going to have my motor force, and it's going to be subtracting force due to friction, so we have to overcome it, and it also has to overcome gravity pulling it down the slope. So it is force of the motor overcoming those forces combined equals m times the acceleration of the bike. So solving, force of the motor is unknown, minus force due to friction, we're given a flat value, so just 1,000, plus gravity, Fay. So from the previous page, it's force due to gravity. So that's mass, so the 175 times 10, because we're using 10 for this particular course, multiplied by sine of the angle, so sine 35. So there is your force pulling you down. Oops, there should be an X above. Maybe I'm causing a little bit of confusion here. Sorry, FAX is the subscript. All right, so it's FAX that we're looking for there. And that's equal to mass times acceleration. So again, it's the 175. And we know that she can accelerate at 3.5. So doing a little bit of calculations here, we find that. So we find that we get 2003.8, which is equal to the 175 times 3.5, which gives us 612.5. Isolating for your motor force, we find that the motor has to generate 2,616.3 newtons, and that would be forward or up the slope. So therefore, the motor must generate, or is generating, 2616.3 newtons, and I guess up the ramp, forward, whichever notation you're going with there. So there we are. What do we got here? So my final example, a ramp is inclined at such an angle. So they don't give us an angle apparently. So there's theta, that a wood block begins to move down the ramp. So there's my wood block at a constant speed. So that means it's like the sticky shoe experiment in grade 11. The shoe just starts to move. All forces are balanced. So that means that your force due to friction, opposing motion, and FAX are going to be balanced. So the shoe starts moving, so to speak. So we have that situation there. I'll put my FG on for calculation purposes. There's my normal force. So there's the diagram completed. Determine an expression that will define the value of static friction. So we're looking for static friction here. All right, so we have, we'll start with FU ma. That's where everything starts. The unbalanced forces are equal. So FU equals MA. So that tells me that this side of the equation is equal to 0. On the other side, we know that the driving force, FAX, has to equal or subtract force due to friction. They're going to be equal to each other. So FAX is equal to force due to friction, which is not an overall shock here because I already wrote that down below. But now we can do our substitutions. So we know that FAX, that force, is your force due to gravity, and sine theta, and it's going to equal your force of friction, which is mu, we're looking for static, multiplied by your normal force. So force due to gravity, mass, which is unknown. So it's just going to be m. And for argument's sake, I'm just going to leave gravity out of this. I'm not even going to calculate it at this point. There's no sense if m is unknown. I'm looking for an expression with mu s. What's our normal force? Well, from the previous slide, you knew it was force due to gravity. And in this case, it is cos theta. All right. So I'm going to leave that one side the exact same. I don't have many numbers at all here. Force due to gravity is just mass times gravity cos theta. We're going to isolate for mu s, or our coefficient, so I need to divide both sides by mg cos theta. And if you look on both sides, those all cancel on your right. On the left, the masses cancel, the g's cancel, and you're left with sine theta over cos theta equals your coefficient of static friction. Sine over cos is tan theta. Now, if you think way back to grade 11, the sticky shoe experiment, you lifted the board. So you had a board with your shoe on it, and you pivoted it, and then when that shoe started to move, I told you in that experiment, hey, measure that angle, and mu s equals tan theta. Well, there's your proof now that I wasn't just making stuff up, making you do random labs altogether. There is the proof as to how static friction is calculated. Okay, pretty neat, eh? I can tell by your enthusiasm after 3 videos that you are super pumped and super excited with this end result. So there you go. Definitely a longer video, but also you're going to be spending a couple days doing the homework, so keep that in mind. Here's your homework, page 118, 37 to 48, and I do believe there is a handout, and that is for the incoordinate planes. So I'll have to double check. Make sure you ask in class. It's probably in the journal binder, where you already have it in your possession if it does exist. So good luck. Any questions? Don't be afraid to ask them in class.